Greetings, scientists, junior scientists, and citizens of this great, big, weird, wild, and wonderful world in which we live. As always, I am your humble science communicator, the Great Orbax, here from Physics Hollywood, California, at the University of Guelph, streaming from our secret location. Welcome everybody in. Very excited to see. We've got a good selection of people already here. People greeting us from the U.S., from Canada, from all over the world, and it's an exciting one this evening because we are going to be talking about the concepts and ideas behind space exploration with a couple of incredible guests. Now, as always, for those of you who aren't familiar with how our streams work here, we'll be doing a live quick Q&A as well as chatting to our guests. Feel free to ask questions in the chat, and we'll be able to bring them in. We'll get to all of them. Oh, we got somebody from Guelph has said hello in the chat as well. And we'll try to get to everybody as time goes on. Now, we might as well get right to it, I suppose. It's an exciting one. Some of you are watching on our Guelph Physics YouTube and Facebook. Some of you are watching from the Orbax Pepperdew Science Facebook as well. So greetings, one and all. I've written an introduction for this evening. That's how excited I am about our guest this evening, is that instead of doing my usual wing it, I've written an intro, so we might as well start there. One thing we can say about our pursuit of the great unknown and the vastness of space is that it captivates us like no other field. Few people have looked up towards the stars and not had a fleeting thought as to what happens up there. It is often said that space exploration brings out the best in humanity. Scientists from across the globe work together passionately, share information, and build incredible devices to expand our understanding of the universe beyond the 10 kilometers of up within which most of us are trapped to exist. And why is this so? I remember one of the first science books that I was fascinated by as a child was an astronomy book of my dad's from his time at university. I'd pore over the pages, fantasizing about the idea that someday I might get to fly across the galaxy like my heroes on TV. For so many years now, our adventures beyond Earth's atmosphere have been deeply rooted in the ethos of scientific discovery. Yet lately, there's been a resurgence of the idea of a space race, but this time with billionaires striving to launch themselves into the heavens. So we're going to talk about all of this tonight and more. Undoubtedly, our guests this week are experts in their fields, and I'm so excited that we're lucky enough to get them on tonight and to give you a chance to ask them some questions. So I'd like to, without any further ado, bring in our guests. We have continuing Guelph Griffin and Guelph Physics graduate time and time again. That's right, 3 times Guelph Physics graduate. Joining us from Washington University is Dr. Scott VanBommel. Bring him in. And we've also got, and I want to make sure that I get her title correct, we have got joining us from the Planetary Society this evening, the Communication Strategy and Canadian Space Policy Advisor of the Planetary Society, Kate Howells. Bring her in as well. Good evening, everybody. How are you doing tonight?
Hello. Doing very well.
Howdy.
Thank you.
Very exciting. Well, we've got already the everything is lighting up. We've got Quinn and Zoe saying hello. We've got Michelin from Prince George, BC, who's stoked to be here. And so you are 2 passionate science communicators who talk about all things space and are involved in all types of work with space policy, and even have put stuff onto other planets. I'm looking at you, Scott. So one of the things that we try to do with this is to start out by humanizing our guests to an extent.
Humanizing or humiliating?
And getting some sort of insight from them. So I'm going to ask a quick question of each of you. It's the same question, so you'll have time to think about it, whoever goes second. But the question is this: if you were to tell someone about the most exciting thing about your job or your research, what would it be?
I'll go first, Kate.
Thanks.
So for me, I think, and I'm sure we'll touch on this later in the show, but I'm very fortunate with what I get to do in that I'm essentially part of a team that's exploring Mars by proxy through spacecrafts and robots on the surface of Mars. And for me, what's most exciting about that is, yes, I get to work with world leaders in their field and I'm constantly learning, but we're also exploring another planet. We're seeing things for the first time that no eyes have ever seen before. And we're all doing this with the focus of learning more about our place in the solar system, our origin story, and we're learning more about our home, Earth, in the process.
Wow. It's pretty well said, Kate. You're gonna have to follow that. What have you got to tell us?
Well, I mean, I do get asked this question sometimes of whether I like my job and why I like it. And I will say that I I love my job, and the thing that I love the most about it is that I just get to learn about the coolest stuff in the universe every day. And my job is to digest all of that and then translate it and put it back out to people in language that they might understand, if they're not scientists. And that's a real pleasure because I get to just focus on the coolest stuff. I don't have to pay attention to the details if I don't want to. I just focus on what I think is interesting and relay that. And there's a lot of really interesting stuff going on in space science and space exploration. So it's a real pleasure and honor to get to learn about it all the time and talk about it.
Well, you're right to say that. It's kind of an interesting thing that I feel like now we're at a moment in time where there's a lot of stuff happening quickly and a lot of stuff happening that's kind of never happened before in all of science and in physics. Are we seeing kind of a new, I mean, I hate to use this term, and it seems kind of cliche, but a new space race that's occurring? Or are we just seeing that we're in a time period now where there's more and more possibilities because of where we are with technology?
I would venture to say that calling this a space race, calling this sort of this new era of human space flight with private companies paying tourists up on very short trips, just barely into space, that's a whole new thing for sure. And I know that it was framed as a race between Richard Branson and Jeff Bezos to see who could get themselves up in their own rocket first. But I mean, now that race is over, I think we're in a space capitalist scheme, perhaps, but I don't know if I'd call it a grand race in the same way that we saw in the 1960s with the US and the Soviet Union.
Scott, what are your thoughts?
Yeah, I think Kate hit the nail on the head there. A capitalist venture is definitely one way to look at it, and really it is just barely scratching what we consider an arbitrary definition of space. When you mentioned space race, to me, the past launch window to Mars, we had multiple missions arrive, all from different countries. So currently on Mars or orbiting Mars now, we have spacecraft from European Space Agency, NASA, India, United Arab Emirates, China also has a rover on the surface. So there's a lot of international impetus to explore Mars, and it's becoming the new frontier of pushing the boundaries of technology. And I don't think it's out of the realm of possibility that it will be kind of the race in the not so distant future, building off of momentum from the Artemis program.
Yeah, if I may add to that, I think when you see a race, it's usually for some reason other than scientific discovery. So the Apollo program wasn't about conducting lunar research, even though moon rocks were brought back and lunar research has benefited from that. And, there are good spin-offs, but ultimately the space race in the 60s was about US versus the Soviet Union, capitalism versus communism. It was these big geopolitical things where space was the arena for competition. And I think, again, seeing, competition for profit, perhaps among private companies, you could call that another kind of race, perhaps sending humans onto Mars, seeing whether it'll be maybe a Chinese astronaut or taikonaut or an American who's the first to set foot on Mars. That might also be some kind of race. But again, those aren't really science objectives. So the collaboration and the sort of sharing of information that we see in all the science missions that Scott just mentioned that are all at Mars right now, I mean, that's what it's all about, I would say. The competition is not so much about space.
Well, and I mean, it brings up an interesting idea as well, right? Where before, things were sort of politically driven in the past to get people up there. Now that we can get up there, and we have this altruistic view of science that we're going to be doing the research while we're up there. Is that in itself enough impulse to put pressure on people to get up there? You know what I mean? When there was so much of a political pressure to get all these people to work together and to end up with people being on the moon or to get things up into space. I'm curious if we're going to see as much fervor for it continuing further in the future. But without going too far into our discussion of space, one of the big things that we always like to talk about is we have viewers of all ages, of all walks of life who watch the streams. And I kind of wanted to get into how each of you got to where you are today, kind of what you went through with school and what inspired you. And maybe we'll start with Kate this time. Kate, can you give us a little elevator pitch of your life? Just boil your entire life down to about 3 minutes for us.
Yeah.
And let us know what got you to where you are now and what inspired your passion for science and space.
Yeah, so I took a winding path. I grew up here in Guelph, and I went to university, not really with any clear idea of what I wanted to do. I thought I wanted to be a French teacher, and I went to McGill in Montreal and discovered that there were many better French speakers than me in Montreal. And so I quickly shifted into psychology, which was actually just something I was really interested in. And then about halfway through my undergrad, pursuing a BA in psychology, I picked up at a used bookstore the book Cosmos by Carl Sagan, which I recommend to everybody, regardless of your level of interest in space. It's just such a beautiful look at space and science and discovery and the sort of epic tales of how people do these incredible things to discover, wonders of the universe. And I was just completely blown away. I was moved. Obviously, I love it, and it sparked an interest in space. But as I said, I was halfway through a BA, and so I thought, okay, I'm not going to start from square one and go into science or engineering. I just started looking for ways that I could maybe get involved in some other capacity. I also, at the same time, I was doing some research in a lab for my undergrad thesis, and I was kind of getting a little disillusioned about how science is conducted. And so I decided to go to a master's program in science policy, thinking that that might be a way for me to affect science in some other way. And I got into a program at George Washington University in Washington, D.C. that offered a focus in space policy. And I thought, aha, this is my chance to do something that has to do with space. I mean, up until this point, I had thought that there would be no real way for me with my, psychology knowledge to do something to do with space. I remember McGill, when I was an undergrad, had a space elevator team trying to compete in this competition to design a functioning space elevator or some concept that would work. And I thought, I'll just volunteer to bring them coffee or something. Like that's if I can contribute in some way, I want to do it. But so I got into this space policy program. I was in Washington, D.C., which is the center of NASA's space policy workings. And for people who don't know what space policy is, I mean, I didn't know what it was until I got into this program, to be totally honest. It's basically how the government makes decisions about what its space program is going to do. So where funding goes, what missions are selected, international relations and cooperation and treaties and all that stuff. So I got a really deep dive into how space exploration and space science work from this sort of higher level. However, by the end of my first of 2 years there of the program, I decided that this was not actually the path I wanted to do. I am not somebody who thrives in a government culture, and I did not like living in DC, and I decided that this was not the path for me. But meanwhile, I was becoming very convinced that my path was in public education and communication around science, because that's what I was really passionate about. And luckily, while I was in DC, I met the folks who run the Planetary Society, who were interested in expanding their operations into Canada. And I was very keen to return to Canada after spending a year in DC. And so I got involved with them, and I've been working with them for about 8 years now. And it's just been, I mean, I feel very fortunate that my path worked the way that it did. I got a lot of lucky breaks, but I guess the sort of moral of my story is that I just kept following my nose and listening to what my values told me and listening to what my interests were. And here I am now talking to you.
Yeah, it's interesting. You know, I know, Kate, you and I have talked about this before, but it's funny. When you're a student, you often say, oh, I've got this one path that I have to follow, and that's where I'm going to end up. I mean, I'm somebody as well who's changed path multiple times and continues to change paths multiple times. And it's just an important thing to recognize the fact that it's not about, you know, trying to end at this individual job or position. It's about the journey getting there. And that really brings people from multidisciplinary backgrounds into stuff like this. And it's probably best that you had so much experience in various things before you even joined in. Yeah,
I mean, especially for the kind of work that I'm doing, I think it's beneficial that I don't have a very intense science background or engineering background, because the scientists that I know who work on space stuff, they are so, I mean, I don't know if this is true of you, Scott, but like people who are so close to it can be so excited about the tiniest little things, and it can be difficult to communicate that to people on the outside. And because I never got that deep into science or engineering or anything, I can understand what a scientist is telling me, and then I can understand how it might sound to an average person and like do that translation. And it's worked out well for me to have had this sort of random path and this different background. But I do admire the scientists and engineers who actually do all the cool stuff that I just get to talk about.
Well, it's interesting that does you know, sort of lead us into Scott. Or the chat's already lighting up, and we'll get to your questions. But before we get to there, I do want to get a chance to hear Scott's perspective of how he got into space and into science, and what brought that to him.
Yeah, so my path's been pretty serpentine as well. But as a kid, I was probably pretty annoying for my parents, constantly asking questions about anything and everything, essentially just trying to understand the physical world around me. But I ultimately went to Guelph, interested in becoming a high school science teacher at one point. And after first year, I was thinking about which path I wanted to go, and I really enjoyed the first year courses that Joanne O'Mara and Martin Williams had, and took physics. And come fourth year, I learned of a program where you could do research with a university professor. And lo and behold, a professor had just arrived from Germany who had physically built hardware with his bare hands that was on the surface of Mars. So I gathered my composure and all the courage I could to knock on his door and see if he would take a kid from small town tobacco country, Ontario, as a fourth year project student. And that ultimately led to a master's project. And right around the end of my master's, little spacecraft worth a couple pennies, known as Curiosity, was landing on Mars. And it was a perfect opportunity to get involved with that mission from day one. And that led to a PhD, which I completed in 2017, and short stint in Antarctica. Ultimately came back and got a position here at Washington University in St. Louis, where I continue to work on Curiosity. Had the opportunity to work on the Opportunity rover, which we lost in 2018, and was selected to be a participating scientist on the 2020 rover Perseverance.
Well, that's pretty great. We've got a shout out here in the chat. Somebody claiming that Professor Williams' first year physics class was one of his favorite classes of all time, which I guess just means that I never taught them. So it's interesting to see these types of comments pop up. But it does.
I'm also hurt because James was one of my students in electronics. I would have thought that would have been one of his favorite classes of all time. But what's that tell you?
Yeah, I don't know. I mean, I guess. I mean, to each their own, right? But you know, we have a lot.
I can't compete with Martin. I just admit that right out of the gate.
We have a lot of questions coming up, and I think some of them are kind of tying in directly to this. So I guess we might as well just jump right into it, which is, you know, this idea about leaving technology up in space. I mean, you're working on the rovers. We lost Opportunity. It's on the surface now. There's presumably there'll be many other robots on the surface of Mars that aren't going to be making their way home. we've got a question from that's popped up from Bruce, and it has to do with the extreme number of satellites that are continuing to populate sort of the upper atmosphere. And I wondered, Kate, is there anything that you have want to address this in any way?
Yeah, so this one's tricky because whether these Starlink satellites are a good thing, the answer will really depend on who you ask. So on the one hand, they promise to deliver high-speed internet to everyone around the world, regardless of whether you're in a really remote location or in a city. And that's good. Communicating via the internet does a lot for the world, but they're talking about launching tens of thousands of satellites into low Earth orbit. And that is going to be a big, big increase, like many, many times the number that we have right now. And there's already concern about cluttering orbit. So realistically, from a science perspective, what the problems that this causes have to do with any kind of observation of space that we're doing from the Earth. So ground-based observatories, whether it's optical or radio or any kind of way that you're observing the heavens from Earth, you are going to have that observation disrupted by these satellites. So that's not great. And the science community, I think radio astronomy in particular, they're not happy about this happening. And I totally understand that. And I think that it is a problem. And the thing is that there just isn't really a governing body that can say, you know what, no, you're not allowed to do this. I mean, there are governing bodies that regulate what you can launch, but they're not coming from the perspective of, protecting the integrity of science observations. They're looking at, are these things going to crash into each other? Does SpaceX have plans in place for safely deorbiting satellites that are defunct, or repairing them on orbit, which seems unlikely to me. Anywho, it's challenging. It's going to make the area a lot more crowded. From a policy perspective, there is also the issue of the more objects we put in orbit, the more likely a collision is. And a collision is bad for everybody, because a collision between two satellites creates a whole bunch of debris that then can just collide with other stuff and make more debris. If you saw the movie Gravity, you'll know what I'm talking about. That was a great demonstration of what can happen when you hit things in orbit and everything's moving very quickly. So things like Mars rovers are going to be unaffected by this, and space telescopes that are out in orbit won't be affected, and that's great. But it is definitely cluttering up the skies for people who want to look from the Earth.
Yeah, it's an interesting. I mean, at some point, I guess the purpose of space policy is to sort of rectify these kinds of things. And I guess we can look at it from a moral view or an ethical viewpoint of like how much garbage do we throw out there versus what do we get that's a scientific instrument or a piece of scientific equipment to what can be called scientific equipment, but turns out 5 years later is garbage that's out there.
Mm-hmm.
But I guess that's the main purpose of something like having space policy and like having advisors like yourselves to our government who can actually sort of put these things in place and come up with some kind of regulation.
Yeah, and what's tricky with space policy is that each country can decide what it's comfortable with and make its own rules. And there are international treaties, but the treaties aren't enforced by some, global government, right? So like, there's no way if Canada decides to claim that the moon belongs to Canada, that's going against the moon treaty, but who's going to stop us, right? And so that becomes an issue when some country might legalize some activity in space that other countries consider irresponsible or unsafe. And there's nothing that can really be done about it. So it's like a lot of things that we see on Earth, climate accords that nobody's held accountable to, and that kind of thing. It's tricky to actually enforce this internationally.
Scott, how do you see that as somebody who's researching with equipment that is now competing for space on a distant planet? How does that come into play with what you're working on?
What do you mean? In what sense
Well,
specifically?
I'm just curious, when you're choosing to send a mission to Mars, presumably you know, it has to stay away? Are you vying for locations to actually land these things when you're up there, or are you just hoping that the paths of these, even though you're from separate governments sending up separate sets of robots up there, that they'll just never see each other?
So yeah, the thing to keep in mind is that where the rovers land, there's plenty of space to explore. We're not really at the point yet where
Yeah, I
any
suppose it's a
rovers will
planet's
come
worth,
up
right?
and give each other a high five, right? But one thing that people may not consider is that when you have assets on the surface of Mars, the data they acquire is relayed through satellites orbiting Mars back to Earth. And the Deep Space Network is servicing all of the spacecraft out in space. And there are times where you'll have rovers on the surface and you'll have to make a decision, or rather NASA will have to make a decision which spacecraft to prioritize if that overflight can only service one or the other. And in the case of InSight, I believe it landed pretty close to one of the rovers. I should know this, but it's evading me right now. So there are times where you have to prioritize one over the other for downlink. So there is some competition between landed spacecraft for some assets, but as far as traversing and terrain goes, that's not really an issue. And there's plenty of airspace above Mars for satellites to orbit, so we don't quite have that same risk here. But if we are at some point looking to kind of have a more sustained presence on the surface, that will require an increase in infrastructure to enable higher bandwidth communication between Earth and Mars, both on Mars side and on Earth side as well.
Shifting gears here a little bit, but all still within the same realm of topic, we opened with a video about exoplanet exploration. And there's been some questions in the chat about, realistically, what is our future looking like in terms of having crewed space flight below low Earth orbit, of looking at these projects that are going up onto the moon, of looking at the idea of having jumping points or bases for humankind that are off planet.
Yeah, so to the one question there, I believe the CSA has procured one seat on a lunar flyby as part of Artemis. Kate, is that correct?
Yeah, that's right.
Yeah. So yeah, that's promising, but I suspect that we'll see primarily a lot of NASA-based astronauts getting the boots on the ground, especially the first ones. And I'd actually be pretty curious to hear Kate's thoughts on this as well. But to me, the Artemis program, in particular, the Lunar Gateway, is kind of a compromise. One of the things
before we get into that, let's for people who have no idea what the Lunar Gateway is or what Artemis is, can we even start there and come up with a definition of that for some of our viewers?
So Artemis essentially is a follow-up to the Apollo program, aiming to get human boots back on the surface of the moon, and also segue as a launching point to potential manned flight to Mars. And the Lunar Gateway is essentially a space station put into a very specific orbit around the moon that enables pretty reliable transfers between Earth and the surface, and it also can serve as a launching point to go from orbit around the moon to Mars. Anything to add, Kate?
No, that's great. I would love to hear now what you were going to say before Max interrupted you, which is fair to get that definition. I know not everybody knows all the stuff.
So one thing that I've kind of noticed over the years is that the aspirations of NASA, because NASA is directly under kind of, I don't want to say the whims of the American administration, but
That's
really
fair.
Okay, you're the expert here, so I'm glad I hit the nail on the head there. But one administration will focus on the moon, and then the next one comes in and focuses on Mars. So for me, what the Lunar Gateway and Artemis represents is a compromise between both. So that way, we as NASA and the American taxpayer, we're not contributing to one specific goal that then just gets completely transitioned over to something else, and all that progress is lost. So by having Artemis and the Lunar Gateway, we have something that's kind of a bridge between the two, that no matter which direction administration wants to focus, it is still hardware, technology, man hours, investment that can be used for each.
Yeah, to add to that, one of the things that does make the Artemis program and Lunar Gateway program more sustainable and less likely to just get cut. Because yeah, absolutely. A presidential administration loves to come in and say the old administration's plans for space were over budget and behind schedule and looking at the wrong target. So let's cancel that. And we're going to have my new plan. And like, that's very politically safe to do, because I think overall the American public isn't paying extremely close attention, and they don't know all the budget figures and everything. So a new plan always sounds good. So how do you prevent that? One of the ways is to have a project become very internationally collaborative. So now if a new administration comes in, it's less politically viable to bail on the project because international partners will be disappointed. So Canada and many other nations are signed on to contribute to various components of the Artemis project and the Lunar Gateway, and like landing systems, rovers on the moon. There's so much that all plays into this big mission architecture. So I think what we might see will be more like the International Space Station, which is obviously international collaboration between NASA, the Canadian Space Agency, the Russian Space Agency, the European Space Agency, Japanese, all these different countries working together. And that's kept the ISS going for decades. And, unlike the Apollo program, sending American astronauts to the moon, which, although it did have small contributions from Canada and other countries, it was really an American project. And then when the political justification for it dried up, it was abandoned. And I think in terms of what we're going to see for the future of human space exploration, I think it does depend on whether Artemis and Lunar Gateway are successful in establishing a sustainable lunar presence that has scientific value, commercial value, that has sustained public interest and political support, or if this becomes another, okay, we got a Canadian flew in orbit around the moon, but that's as far as it goes because this whole program will just evaporate. And I'm hoping it'll be something more sustainable and practical, but you never really know with human spaceflight.
And I was just gonna say, there's always the added risk whenever the reward comes greater than 8 years after the investment.
Yeah, absolutely. Yeah, there's a new plan from a new presidential administration. They have no real incentive to make it a right. realistic plan, because they're not going to be around when the results are showing. So
it's interesting to me that, coming from as a layperson who's not actively involved in this, albeit an incredibly smart and handsome layperson, but still nonetheless, it's one of these things where I'm still looking at space from my perspective of, I want all humanity to be working together, to be creating these projects, to be learning and bringing it all in. And what I'm seeing and what I'm hearing is it's as politically driven as anything else that we come across in our day-to-day life, potentially.
I would say that human spaceflight is. Space science, totally different picture. And I will clarify that I am professionally an advocate mostly for space science. I think human spaceflight is interesting. It can be very valuable to the public good, generating science, having, medical spin-offs, technological spin-offs. But a lot of what human spaceflight is, in my opinion, is geopolitical, like positioning, showing who's rich enough to have an astronaut land on Mars, because it's very expensive to do human space flight. But space science, it's much more internationally collaborative. It's less flashy, but it actually does generate information that's valuable to all people. Like if we were to find evidence of life on Mars, that has implications for everybody's understanding of their place in the universe. Having a Canadian fly in lunar orbit is cool, but what does it really do for you? So I think they're very different, and people equate human spaceflight with space in general all the time. But I do really see that science and human exploration as very different things.
If I could just touch on that, Orbax, quickly.
Yeah,
I
go for it.
completely agree with you, Kate. One thing I do want to add, though, is you mentioned a Canadian astronaut orbiting around the moon. And while, yeah, the scientific value of that, the immediate scientific value of that may not be obvious, the impact on young people to be inspired and pursue higher education and contribute to society through innovation and scientific research, you can't really quantify that. So it's hard to kind of gauge the impact that can have, but I think it's definitely not negligible.
Yeah, I agree with you completely, and there are definitely other good reasons to do human exploration, just for the sake of seeing, what is possible, what can humans accomplish, especially when we work together.
It's in our nature too.
Yeah, there's something beautiful about it, but I think that like Jupiter is more beautiful than that, so that's where my allegiance lies.
Well, we'll get into your Lucy mission soon enough, Kate. For now, though, I would like to as many of our viewers know, we have our roving reporter, Mel, occasionally comes in and joins us, even though now she's no longer an undergraduate reporter, but our recently undergraduate reporter. So let's welcome Mel into the stream. How are you doing tonight, Mel?
Hi, everyone. I'm good. It's so nice to meet you, Kate. I'm super excited. And Scott, I'm so happy to get to talk to you again.
Yeah, hopefully, what was it, Instagram or Twitter or whatever it was last time we tried to do something like this went down. Hopefully that doesn't happen again.
Yeah,
so I'm bringing Mel in for a series of specific questions, and this one ties directly into what Kate had mentioned about the potential of finding life out there in the void. Mel, go right ahead.
Yeah, so this question comes from a great friend of mine. So Mara is asking, do aliens exist?
They can see Orbax on the screen, right?
Well, I mean, I was going through some books, and there's a whole section in this book about aliens exploration. And actually, as a matter of fact, in my book, there's a whole section on it as well. Scott, I don't happen to have your book here.
Yeah, there's a real slag between the U.S. Postal Service and Canada Post. I'm sure it's just stuck on the border somewhere.
I guess it's stuck at the border. That must be the issue.
Yeah.
But what do we feel about life otherwhere in the universe?
Oh, it's definitely out there. I think the quote that I like, and that's in the book that you showed about this, is rough paraphrased, is that either we're alone in the universe or we're not, and both options are equally terrifying. This idea that life on Earth is the only life in the entire universe, where there are billions and billions and billions and billions of planets and moons and places that could be like Earth. The idea that this is the only place that has sparked life on it is so outrageous when you really think about it. Just the vastness and age of the universe. It would be so unlikely for this to be the only place that life has emerged. The idea then that there is life out there kind of begs the question of why haven't we ever detected it? How are we not seeing this? So I think that my understanding is that life is probably not so common that it's on every world, because we haven't found it anywhere else in our solar system. Scott's trying. Everybody in the Mars Science Division is trying to find evidence of past or present life on Mars. We're looking elsewhere. It's difficult to do that research, so it's a slow process. But the other thing too is that the universe is really, really, really big. Everything's far apart. So even if there were life, the next galaxy over, there's no way we're gonna find it. It's extremely far away.
Always the optimist.
Yeah, no, but I mean, if there were intelligent aliens out there looking for us, they would only be able to even detect, once we started making signs of being alive, in terms of like the chemicals that are emitted by life processes that could be detected from afar, or the radio signals that we are putting out including just like the radio that you listen to. I mean, those waves keep going, and you could potentially detect them, but only at a pretty close distance to Earth, cosmically speaking, because light and all other forms of information in like radio wave or whatever they take time to move through space. It's fast, but it's finite. So you have to be close enough to see or detect what we're putting out there, and it just seems unlikely that there's anything that close. But I'll hand it over to Scott for maybe a more scientific answer.
No, I think you said precisely what I kind of had in mind, is that the numbers kind of speak for themselves, that the odds are that there's something else out there. And the issue is that we will have to have an overlap in both space and time. And if life exists simultaneously to us but is far away, there's just simply not enough time. If it's 1 million light years away, it'll take 1 million years for those radio waves to get here, and who knows what either planet will be like in that situation. Or if it was in our cosmic back door, but it evolved millions of years ago, and here we are now, and they've since, met their own demise, we'll never know that they existed potentially. So it's that combination of both space and time that are the X factors that kind of work against the colossal numbers that, chances are there is or was something else out there at some point.
Yeah.
Well, and even just the idea that should they receive any of this information, that any of it is going to be decodable or mean anything to whatever that intelligence or life form is.
Yeah. Another thing along those same lines is that we only know how to look for life as we know it.
Yeah, exactly.
So when we're digging around on Mars trying to find evidence of past or present life, we're looking for evidence of life as we understand it on Earth, but it could be completely different. We have no clue. We don't know how to look for what we don't know exists. Yeah, it could just be a bunch of Orbaxes.
I mean, I'm just
small.
the humanoid form of giant space jellyfish. It's been well known for quite some time that I'm actually 1,500 space jellyfish combined in a human suit.
Yeah, it's obvious.
Explains the glow.
Well, Mel, does that answer your question?
Yeah, like when I used to think about this question, I used to think, okay, maybe life would be in the form of like bacteria and such. Like there's different forms of life, but the idea that there could be people who can communicate, not people, but some extraterrestrial form that can communicate. It's a very cool thought, and I do agree that it's super probable.
Well, I mean, even one way to think about it is the idea of how we communicate with other forms of life, even on this planet. There's a massive disconnect between an ant, which is a living life form, and us. Mm-hmm. Or, watching a cat and a dog even try to speak to each other. It's difficult for these things to communicate. And I mean, that's just on the same planet with creatures that we generally accept as having some form of intelligence.
And share a vast amount of our DNA with.
Yeah,
in many instances.
I would also say if you want to look for aliens, look in the bottom of the ocean. Like there's so much stuff in there that we have not found yet. We know, I don't know exactly how this works out, but I've heard that we've studied, the visible universe around us more than we've studied the bottom of the ocean. Like there's a lot of mysterious stuff down there. And from what I've seen of the things that we have found so far, that's more alien than anything in the sci-fi book I've ever seen. So that's...
Well, it's funny. That was my question. One of the questions that I had for your pal, Bill Nye, there a couple of years ago when we got the opportunity to chat with him. And that was, when I was growing up, I was always told we're going to have moon bases and we're going to have, semi-domes on the bottom surface of the ocean where we could explore down there as well. And somehow in this whole thing, beyond James Cameron, everybody's given up on the depths of the ocean. Maybe
they found something down there that scared them off.
Oh no! Don't say it out loud. Our stream will get pulled. The views of Kate Howells do not reflect those of Guelph Physics. But Scott, I mean, this does bring up a question of a lot of the work of what's happening on Mars that must come your way all the time, which is, is there life? We found water to some extent. How far does that actually go towards telling us that life could or may have or someday might be again there?
Yeah, and I touched on this earlier, but the real focus of exploring Mars kind of comes back again to understanding our origin in the solar system, in the universe. And when we go to Mars, again, we're, as Kate said, kind of looking for the clues that would be required to be there if life was similar to what we know on Earth. So we're looking for signs of past water. We have found that. We found conclusive evidence that at some point Mars could have supported life. So the next logical step is to figure out if life was ever there. And that's part of what the Perseverance rover mission has been sent to do. But the thing to remember here is that Mars wasn't always like it is today. Mars was once warmer, Mars was once wetter. And around that same time, that's when life on Earth was starting to take hold. And because Earth has plate tectonics and all kinds of erosion, a lot of that rock record has been lost forever. So Mars provides us with a window into a time period on Earth, a time period into nascent Earth where we are ancient ancestors, these singular globs of jellyfish or space jelly, as Orbax was saying, existed. Mars provides us a window to kind of explore that time period. And it's a big if we can ever find evidence of past life on Mars, it'll revolutionize our understanding of our position in the universe. For one, if that life is different from what we have on Earth, we now have two different sources of life in our solar system, which only amplifies the chances that there's life elsewhere. However, if life is the same, now we have the situation where either life on Mars came from life on Earth, or life on Earth came from life on Mars, and we're actually all descendants of Martians, which is what I tend to prefer and hope for.
Well, and there's a lot of talk towards that end that I've heard in the sort of popular sort of ecosphere these days, of this idea of there having been, you know, Martian bacteria or Martian particles on the asteroids that came and eventually maybe started some kind of
we have
life
pieces of
Earth.
Mars on Earth today. There are Martian meteorites. There are several dozen stones. They're thoroughly studied. And they're just ejected from Mars during an impact and happen to intersect Earth's orbit and are large enough to survive entry, and just by pure coincidence are found before they're buried, or they just don't land in the ocean. It's, you know, remarkable odds, but it happens. So chances are there were several instances of that, especially in the early solar system when you had a lot heavier bombardment of the planets.
Well, to slightly shift track here away from conclusively saying that Scott is saying that without a shadow of a doubt there's life on Mars, I probably this is an interesting question that I want to get to before we run out of time, and it's probably something that both Scott and Kate can speak to. And this is again coming to us from the chat. But you know, Canada has kind of this history of space robotics and of being, I mean, it's not necessarily great to say that it's a small, but it is a small but very active role in the technology that's been involved in space. The arms and the shuttles were up there with everybody else. Do we have any sort of is there stuff in the works? Is Canada really carving out a spot for itself in future space missions and in future space tech?
I'll touch on that quickly and hand over to Kate. So the Canadian Space Agency has a lot of information on their website as to what they're involved in and what they're working towards. Obviously, we're known for the Canadarm and Canadarm2. But as far as kind of robotic space exploration, there's a known expertise in Canada for radar instruments, and also the technology that is managed here at the University of Guelph is also run through the Canadian Space Agency, and that's the alpha particle X-ray spectrometer. And that's really an instrument that's perfectly tailored for space flight because it's compact, it's lightweight, it produces, you know, small volume data products, it's incredibly efficient, and it provides really high precision chemical information as to the materials that you're analyzing. So there's a lot of interest there within the international community to fly this technology to rocky bodies such as the Moon or Mars. And I might be a little biased, but I think it's pretty darn cool.
Well, and the APXS has been on several of the Martian rovers to date, right?
Correct, yeah. So the first APXS flew on Pathfinder with the Sojourner rover. It was really the only instrument on there that wasn't a camera, just a bumper on the front. It would drive up to rocks. And then in 2004, Spirit and Opportunity landed, and they had hardware that was physically built by Professor Gellert during his time in Germany. And then Curiosity has an APXS, and now the Perseverance rover also has an X-ray spectrometer that was built off a lot of the lessons learned from its APXS predecessors.
I will just add a couple things that I'm aware of, which is I think generally Canada's space agency does a really good job of balancing sort of aspirational out there projects with really pragmatic work. So a lot of what our space agency does has some like a much more direct benefit to people in Canada. So one of the things that comes to mind is remote sensing. So looking down back at Earth from satellites and understanding what's happening with the changing climate, monitoring the ecosystems of Earth or the like terrain in the north, for example. We do a lot of remote communication, satellite communication, again, for connecting remote communities in the north. Telemedicine is another thing, again, with this direct impact for people in the north. And that does have great like spin-offs into space exploration. So I know that Canada contributed an instrument to the OSIRIS-REx mission, which went out to an asteroid named Bennu and grabbed a sample. And the Canadian instrument, I believe, mapped the asteroid first from afar to get a thorough understanding of what the terrain was like, so that when the spacecraft went to go grab a piece of sample, it knew what it was going, like where it was going. So that same kind of technology can have applications that are relevant to what Canadians need, and also relevant to science and exploration. And I know we have our fingers in a few other pies, and we're doing a few other cool things. I know there's a researcher at University of Guelph, Mike Dixon, who does research on growing plants and produce in extreme environments. So again, it could have applications in the north. It could also have applications on Mars, and a lot of his research is focused on sort of Mars simulations or space station type environments. So again, it's kind of taking a pragmatic approach, because we have a limited budget. We have to be scrappy and hit two birds with one stone when we can.
Well, it's kind of interesting, because most of the space science that I've seen has come out of other projects that were always started as investigatory tools here on Earth, and have just been able to be applied to the sort of space exploration element of it. Which is interesting. Well, I mean, we got a good question here that's come up in the chat, which is one of our fundamental services here is trying to connect young people with how they can go forward and what paths they can kind of take for a career. How does somebody get involved in the space industry, either from a policy perspective or from an engineering and building perspective?
After you, Kate.
Sure. Well, as I said at the beginning, my path was a little strange, so I don't always have the most direct advice for, do this, then do this, then do this. But one of the things that I found over the course of my career and when I was a student is that the more you can connect with other people in the field, whether it's other students with similar interests or people who are already in their careers, the more opportunities will come your way. I've also found that the Canadian space community is smaller than you might imagine, and very welcoming and very encouraging of students who want to get more involved. So to name some specific things that I would recommend, organizations like Students for the Exploration and Development of Space, which is an international organization with there's a CEDS Canada that does conferences, and I think they sponsor research and that kind of thing. Get involved with them. The Space Generation Advisory Council, which is run through the United Nations, is an international group for anybody aged 35 and younger who is interested in space. You don't have to have any credentials. You just have to be interested, and it's free to join. And they do conferences. They have networking events. They have all kinds of resources to connect young people with each other, and also with people further along in their careers in space. If your university has like an astronomy club or a science engineering or space engineering association or anything, just join stuff and network and meet people. volunteer at conferences. Just the more you can build relationships, the more opportunities will come your way, and you never know what that might lead to. So that's my overall advice.
Scott, can you hop in on this?
Yeah, the only thing I would add to that was perfectly said is just to put yourself in the best possible situation you can. So work hard at school, take courses that you think will be most relevant for the career that you want, and then also believe in yourself. Take that risk to, in my case, there's this NASA researcher from Germany who just arrived, who built things on Mars. It's pretty intimidating, and just go and ask and see what happens and believe in yourself.
Well,
Yeah.
that is the thing, right? I mean, it so much of this all comes down to just going and taking the risk. And I mean, I think anybody is better off to sort of risk it than they are to walk away and sort of fear or always regret that they never asked in the first place. Mel, what do you find in terms of perspective from a young person's point of view? How is this affecting you?
Affecting me, or do I have advice?
Yeah, either way, whatever you think. I mean, you're recently coming out of what, a 7 or 9 year undergrad. No, but you're recently coming out of undergrad. What would you recommend for a young person who's still going through what you've just finished?
Yeah. You know what I found after graduating? When I was in my undergrad, I always thought it's going to be so hard for me to find something I like. It's going to be so hard for me to get a job. When I got out of undergrad, I cannot explain how easy it was for me to find jobs. And that's because physics speaks for itself. I worked hard in school. I really didn't see my worth when I was in undergrad. And it wasn't until I graduated where I said, look at all these transferable skills that I have. It's all about, looking at what you have and optimizing it and capitalizing on that, on the experience that you have. Even just working with Orbax and the opportunities that I had in the physics department. I got involved in the physics department. I did some research projects during the years. And that's what employers saw. That's, it gave me so many opportunities. And then at the job that I am at now, and I'm starting my career, after I got hired, they told me that they had lots of candidates that had years of experience in the field, but they wanted me because of my physics background and because of everything that I did with the department. And so I think my advice would be to get involved and to know your worth, see how much you're worth and all the experiences you have, like capitalize on that.
Absolutely.
Yeah.
So I guess the advice to Foxcube is to get heavily involved in physics as an engineer.
Yeah, switch it to physics.
No, I mean, I think
Yeah.
you do make a valid point, Mel, is understanding that, I think it's difficult for people in any job, any career, anything you're doing. It's difficult when you're in the thrall of a project, whether it's completing an undergraduate degree or whether it's working on a specific project itself. It's difficult to see out of that or beyond that. And, once you have a little bit of distance from it, you kind of see everything that you can offer. And I think this whole panel proves that whatever you're interested in finding or pursuing, just go after it and pursue it. And you'll eventually find how you fit into that whole world. I guess we're getting close to probably wrapping up here. We're of course, going to bring back to Mel's closing question, but I wanted to throw this to the panelists as well. And we can cut this off at whatever point we need to. But there's been a lot of talk about Mars. We've talked about the moon. There's been some questions in the chat about other planets, and I feel like we'd be lax to not mention the Lucy mission that's just begun, especially since Kate requested we prepare some material for it.
We don't have to. This has been a really good conversation, and I've enjoyed this. I am a huge fan of this mission, Lucy, that just launched, partly because my mother's name is Lucy, and I think she's watching right now, so I have to give that shout out. But it's a really cool mission. I will take 2 seconds to talk about it because I'm all jazzed up about it.
Because it is, we are seeing that we seem to focus so much on our neighbors of Mars and of the moon, but this is something that's going to take us beyond that to explore places we've never explored before.
Yeah, so the Lucy mission in a nutshell is that it is this little spacecraft that launched on Saturday and is heading out to as far from the sun as Jupiter. Now, people might think that that means that it's going to Jupiter, but it's actually going to be extremely far away from Jupiter, because Jupiter's orbit around the sun is like 2 or 3 billion kilometers long. It's really huge. So where this mission is actually going is to 2 clumps of asteroids that are orbiting sort of alongside Jupiter, but millions and millions of kilometers away from it. But they go around the sun at the same distance as Jupiter. So this mission is going to go visit 7 of those asteroids, doing this crazy trajectory where it has to loop back around the Earth and then go back out there, and then it is a magnificent mission. And it's going to study these asteroids that are leftover remnants of the early solar system, when the planets were just forming. Leftover bits of rock that didn't coalesce into planets are just left out in space as asteroids. And so this mission is going to go study them. And it's really cool. Once it's done, I think the thing that when I learned about this is what got me really excited about Lucy, is that once it's done this crazy trajectory to visit 7 of these asteroids.
We can bring up that trajectory.
Yeah.
Saksham, do you have the Lucy trajectory there that we could bring up?
Anywho, once it's done this crazy trajectory that you'll see in just a moment, it's going to just keep going around the sun, because what it's doing. So yeah, you can see Lucy is in blue, the Earth is green, and orange is the orbit of Jupiter where it's heading. And you can see the little clumps of grayish asteroids out there. So it does like this very complicated trajectory where it's using the gravity of the Earth to fling itself out further as it passes by, and then it visits some asteroids, and then it comes back towards the Earth, and it flies by it again. And yes, and then it goes back out to this other set of asteroids. And like, no mission has ever done anything like this. This is super complicated stuff. Calculating exactly how close to get to the Earth when it's flying by it, so that it picks up speed, like by tagging along to the Earth's velocity as it moves around the sun. Like, it's all very cool, complicated physics stuff that I could never do myself, but I can at least appreciate. And then once it's done all of this, because this whole crazy trajectory basically has the sun still as the center of it, like even though it's looping around, it still ultimately is going around the sun, because everything is going around the sun. And once it's done visiting all these asteroids, it's just going to keep going around the sun for millions and millions of years. This spacecraft is just going to keep hanging out in the middle of nowhere in space. And I think that's really cool. And it's got this plaque on it with words of wisdom from various people of Earth. Here, we've got the plaque.
Words of wisdom, like from Yoko Ono and Ringo Starr.
Yeah.
As well as Albert Einstein and various different poet laureates as well, even.
Yeah. And the idea is that maybe some catastrophe is going to happen on Earth someday in the next million years that wipes out human civilization, but some humans stay alive, and over generations they build back up a civilization again, and we develop a space program again, millions of years later, and that space program detects that there's this thing out there that is some kind of technology, and then they go and find it, and then they read this plaque. Like, that's the idea behind the plaque, which I think is just such a wild and beautiful idea. And space people, I mean, Scott, I wonder if this resonates with you, but I find that space people are all kind of poets inside, and have these really grand visions of the majesty of what they're involved in, and it comes out sometimes with missions like this.
Yeah, there's definitely something poetic and romantic about space exploration and the universe in general.
I just think it's such a beautiful thing that millions of years after civilization rebuilds, the words of Yoko Ono will still be there for everyone. I had this question, Kate, as you were talking, and it's come up in the chat as well. The looping trajectory there, how long does that take before it goes into the solar orbit?
This is also wild, and I love it. So that's a 12-year trajectory, starting on this past Saturday, 12 years until it finishes its mission. But out of those 12 years, the total amount of time that it's actually going to be close enough to an asteroid to be able to study it and do the science it's set out to do, cumulative across the 7 asteroids, that total amount of time is 24 hours. So 12 years of traveling. This is how big space is, people.
Science.
You're out there, you're just waiting for a long time. So the scientists on this mission, they have to just wait. I think the first asteroid it reaches will be in 2025. So they've got 4 years to wait. And then they hurry and do all their data collection and all this stuff. And then they just have to wait for another like 2 years before it gets to the next one. And they have like 2 hours to collect data. It's crazy.
Like a sequel to New Horizons.
Yeah, exactly.
So you're saying some of the younger people in our stream right now could actually do their PhD on the Lucy mission's data that's coming back in another 12 years.
Absolutely. This is the weird thing about space as a field to work in, is that you get all excited about these things that aren't going to happen for decades, and then like children could be working on the missions that are like being planned right now. By the time they're actually being implemented, the kids in kindergarten are going to be the ones running the mission. So it's really cool. Sorry, I know I'm going on and on, but on my works, we have like an organizational calendar of external events to keep track of, and the calendar goes up to 2034 or something like that. So like I've got my Google Calendar is got that date.
So 13 years of Christmas parties in between now and the end of your calendar. And I guess somebody seems to be happy that
my mom. Yay. Thanks, Mom.
But no, it's incredibly interesting and inspiring kind of thing. And I think space does bring out an inspiration to everyone. And I've always found the exciting thing about it to myself is that it kind of doesn't matter where you are in your scientific studies. It kind of doesn't matter how much education you have. You can always look up and wonder what's going on up there. And I think it's just been a curious passion that every naturally curious person has ever had, to look up there and try to wonder what's going on.
We're all born scientists.
Mm-hmm.
So, Mel, I guess we'll give you an opportunity to ask your closing question. And thanks again for coming back, even though you're no longer required to by the university.
See, now you know that I actually genuinely enjoyed it. So, I mean, you both have led such exciting lives separately, so I'm actually really excited to hear your answer to this. What would you say would be the most exciting day in your career or in your education? Just, I guess, your most exciting day.
I'll let you take this one first, Kate, unless you want time to think.
No, I would say that there are two answers. The first is the day that I got accepted into space policy school, and I knew that I was actually going to be able to do something with space in my career, potentially. That was absolute highlight, most exciting. But the other was seeing a rocket launch, seeing a really big rocket launch. That is such an exciting experience. I got to see the Falcon Heavy from SpaceX, and the boosters coming back and landing and all that, and it was absolutely unreal. It was so thrilling. Cool. It was really cool. Yeah.
Wow.
What is that
Jealousy
like watching
through the roof?
What's that like watching those boosters reland? Does it just look completely bizarre and fake?
They were landing so far away from where it launched that it was hard to see. You just kind of were seeing these little like a tic tac, really far away coming down. But it was knowing that that's what I was seeing was so exciting. But the launch itself, I mean, you feel it in your bones. Like it was 2 a.m. and it lit up the sky like it was noon, and you feel and hear the sound, and it was just, wow. It was unreal. And I don't know if anybody has ever heard of a launch nebula. I encourage you to look it up on Google Images. Launch nebula. I didn't know this was a thing, but like once the rocket gets high enough, its exhaust is high enough that it's catching sunlight, even though the sun is not visible from this part of the planet. It's like high enough off the ground that it's catching the sunlight, and it illuminates, and it looks like some kind of jellyfish or something up in the sky. And I was standing there watching this saying, what am I seeing? What am I seeing right now? And my mind was blown. So yeah, that was the best.
Wow.
That's exactly it. Well done. That was quick.
Good work, action.
Yeah, extremely cool.
That's a tough one to follow, Scott.
Yeah, I was fortunate enough to be in person for the Curiosity launch. Perseverance, obviously, with COVID, that wasn't really possible. But you know, looking back, I didn't really appreciate at the time the excitement of being in person for a landing. Obviously, not on Mars, but at the NASA facility that was handling the entry, descent, and landing. You know, I was all wide-eyed, and it took a while to kind of really appreciate what I experienced. But the thing that I'll always remember is within the first month of working on the mission after Curiosity landed, we're living on Mars time, synchronizing our work schedules with the rover's day. And there's a slight anomaly roughly a month into the mission, and we had the opportunity to do something. And I just came up with an experiment that we could do given the cards we were dealt, as the plan was kind of pushed a day in the future. And after that was uplinked and the data came down a day or so later, it kind of hit me that I just influenced something that happened on another planet. It's incredibly humbling,
cool,
and you know, participating in these meetings, you're doing that every day, but that first time it really hits you like, wow, this is for real.
At the risk of dragging this out even longer, Sky, you were present, you said, for the descent. What is that 7 minutes of terror like?
So it's funny you ask that. I know there's you've seen the video 7 Minutes of Terror, and for those watching here who haven't, you can Google Curiosity 7 Minutes of Terror. So it's a video that NASA produced outlining how Curiosity was going to land on the surface. Very ominous music. And needless to say, the first time myself and many others in the room for that entry, descent, and landing saw that video was a half hour before entry was set to begin. So because we weren't nervous enough, they thought, yes, this is a great time to do this to everyone. But yeah, the entry, descent, and landing itself, obviously there's just so much at stake. And with Curiosity, it was a novel landing technique, nothing we've done before, where we've essentially lowering this giant spacecraft onto the surface of another planet using a rocket-powered jetpack, right? Just mind-blowing in its complexity. And there's no practice field that you can do this. It's just all simulation, engineering, and if one thing doesn't go right, game over, right? So there's a lot on the line, but the one thing that I'll always remember is being there in person. And Kate talked about how these missions can take 12 years to get there. But there's also the development time leading up to that. So I was new to the team. I was maybe a year part of the team, but there are people who have been involved at that point for probably nearly a decade. And the raw emotion and joy that poured out of them when we got that touchdown confirmed, let's see where Curiosity can take us, was just unimaginable, and I'll never forget it. And I remember I went to shake Ralph's hand as a congratulation. And for those of you who know Ralph, know he's probably twice as tall as I am, and he just picked me up like this. He was just so happy. It's just an amazing experience to be there and to see the fruits of many people's labor finally come to fruition.
I can't imagine. I mean, even when we streamed the Perseverance landing, it was palpable, the excitement, just sitting here in a room by myself while we were streaming remotely. I can't imagine being there surrounded by people who worked on the project. That's amazing stuff. Well, thank you so much for joining us tonight. I want to give you an opportunity. Well, stick around when we end the broadcast. We'll say goodbye to you, but we'll remove you for now. But I wanted to give each of you the opportunity to plug your socials, if people want to follow your research, if people are interested in contacting you to discuss anything. I guess we've got, look at this. Wow, we got tags in the bottom already. Scott, what's the best place for people to find you?
I am not on any social media, so if you want to get in touch with me, you can find me at my work email there. If you don't remember the ticker tape, you can just search for my name and Washington University in St. Louis, and it'll pop up.
Thank you so much, Scott.
Always happy to talk science with budding scientists and scientists in training.
Fantastic. Thank you so much for joining us today. It's a real pleasure to have you on board. Kate, how do people find you? What's the best way for people to follow and support you? I mean, I was able to purchase this book of yours off of Amazon.com.
Please don't buy it from Amazon. Buy it
great,
at your
exciting, and I'm
local.
helping to fuel the space race by purchasing.
Buy it
where
from
do
your
people find you?
local independent bookseller. Space School is F. I'll let you fill in the blank. It's a book for anybody who's interested in space. It's like a coffee table style book, not complicated, just very broad. I do swear in it a lot, so be careful. But my parents have read it, so it's parent approved. Yeah, so I would love it if anybody wanted to buy my book. It is available at local stores, or you can give Bezos your money if you must. You can find me on Twitter at SpaceKateH. I don't check it very often, but please do send me a message. And I would love also to hear from anybody who's interested in learning more about space or talking career stuff. I'm always happy to chat with people.
And of course, you can always sign up to become a member of the Planetary Society, which is a great organization that's always out advocating for space science.
Yep, everybody's welcome. We provide opportunities for ordinary people to have a direct role in space exploration. So check us out at planetary.org as well.
Fantastic. And thank you again so much for your time tonight. We really do appreciate it.
Thank you. It's been so much fun. Thanks for all the great questions, everybody, and for hosting Orvax, and Mel for your questions as well. And yeah, it's been really fun. Thanks.
Great. All right, Mel, I guess people might want to follow you. Where do they do that?
Yeah, just ordinary Mel. You can follow me. You can follow me on Instagram. You can find me on Facebook. I'm on LinkedIn. But you can feel free to message me about any undergraduate questions or anything like that. I think I can provide some expertise on the physics program and how to navigate life.
Well, fantastic. Well, thank you very much as well for joining us tonight. And a special thank you to Saksham behind the scenes, our producer here this evening. Thank you so much for all of you who joined us, and for those of you who were commenting in the sections. We tend to put out at least one stream a month, maybe more. So you can follow us at Guelph Physics on all the socials, be it Facebook, Instagram, or YouTube. Again, thank you so much for joining us. And we're always here if you're looking to reach out, or if you want to connect with any of our experts, we can help put you in contact. So until next time, I'm the Great Orvax, and have a science-tastic day.